Today we are going to be talking about functions and function tables. So what is a function? A function is a rule that applies to a variable. It relates an input value to an output value. So every input, which is our x value, has exactly one output, which is our y value. The function rule specifically is an equation that shows the relationship between your x and y variables. So it can be written in the form y equals something. So for example, if the rule is 2x, it can be written as y equals 2x. So y is twice the amount of x. So when we're given function tables, we are either going to be looking to find input values or output values. So first let's look at finding the outputs. I feel like this is a little bit easier. So what we're looking at here is we are given some input values, which represents x. So these values here, I'm going to be plugging in for x in this function rule and solving or evaluating. So I'm going to plug in 3 for x. So y equals 3 plus 9, so y equals 12. So our output value when x is 3 is 12. All right, what about if x is 16? So again, plug it in for x in the equation. Y equals 16 plus 9, so y equals 25. And then the last one, 80. So plug in 80 for x. Y equals 80 plus 9, so y equals 89. Let's try that one more time. This time it's a two-step function that we're plugging it into. So plugging in, again, all of these values for x. So y equals 3 times an x value of 5 plus 2. 3 times 5 is 15, plus 2 gives me 17. So our output value is 17. All right, let's try it again for 7. So plug it in for x. Y equals 3 times an x value of 7 plus 2. So we multiply first. 3 times 7 is 21. So y equals 21 plus 2, or y equals 23. So our output value is 23. And last one, y equals 3 times an input value of 10 plus 2. So y equals 30 plus 2, or y equals 32. So that's when you're given an input to find an output. We're going to do the reverse now if you're given an output to find the input. So when we do this, we actually are working backwards. So when we plug it into the equation, we're really setting up an equation that we have to solve. We have to use those inverse operations to solve. So let's go ahead and check it out for this example. This time, we are given y values, which we are going to plug in for y in the equation. So I'm going to take the value of 15, plug that in for y. So 15 equals x plus 13. Now we have an equation that we need to solve. I'm going to draw my line down the equal sign. Looking at the side where our variable is, since we're adding 13, the opposite is to subtract 13 from both sides. 15 minus 13 is 2. So our x value is 2. You can always double check by plugging it back in. Is 2 plus 13 15? Yeah. All right, let's try the next one. If y is 93, so again, we're plugging in 93 for our y equals x plus 13. Draw a line down the equal sign because we're going to need to solve. We're adding 13, so the opposite would be to subtract 13 from both sides. On the right, we're left with x. On the left, 93 minus 13 is 80. So our input value would be 80. And then the last one, All right, what about if x is 145, or sorry, if y is 145, so plug that in for y. We've got an equation. I'm going to draw the line down the equal sign. For adding 13, the opposite is to subtract 13. 145 minus 13 is 132. So our input value is 132. All right, let's try that again. We're given the output, the y value. We're going to solve for x. So again, I'm plugging that in for y in our equation. So our equation is y equals 6x. I'm going to plug in 108 for y equals 6x. Let's solve this equation. This time on the side with the variable x is being multiplied, so the opposite is to divide. On the right, we're left with just x. On the left, 108 divided by 6 is 18. So our input value is 18. For the second one here, 132 for y. Setting up that same equation. X is being multiplied by 6, so the opposite is to divide by 6. On the right, we're left with x. On the left, 132 divided by 6 is 22. And one more. If y is 216, let's plug that in for y equals 6x. Now let's go ahead and solve. X is being multiplied by 6, so the opposite is to divide by 6. 216 divided by 6 is 36. So you notice each time the equation looks the same. We're solving it the same way. So it's kind of this repetitive action just with different values.